Alright, welcome to another video called Matched Pair T-Test. The goal of this video is to help you really write the hypotheses because those can be kind of difficult for a matched pair T-Test. And it's always good practice to see the calculator and the entire proof written out. So let's go ahead and go through this. So we're going to start with this question. Police trainees were seated in a darkened room facing a projecting screen. 10 different license plates were projected on the screen, one at a time, for 5 seconds, each separated 15-second intervals. After the 15-second interval, the lights were turned on and the police trainees were asked to write down as many of the 10 license plates as possible in any order at all. So I believe here the goal is to help them remember license plates. So here is their score after the training, and this is their score before the training. And a lot of times in a matched pair, they're going to tell you how to subtract the two lists. We know that this is a matched pair because each one of these officers took the test twice. They took the license plate test before the training, and they took the license plate test after the training. So this represents one officer. This represents the second officer. Okay, so we want to see the difference in training to get rid of the confounding variable of maybe somebody had some previous training or maybe somebody is just a little bit smarter than the next officer. So the goal here is just to look at the change that occurred before and after the training. So what we're going to do is we're going to take, according to this question, we're going to take list A, which is after, minus list B, which is before, and we're going to subtract those. And if you wanted to do this quickly, you could do this in a list. So I know it's a little hard to see because the screen's dark, but this is the after, this is the before. So if I want to do after minus before, I'm going to highlight list 3, and I'm going to do list 1 minus list 2. So you'll see I already wrote all that down just to save us a little time. So those are the numbers that you would have gotten list 3. Now the goal of this problem is to test at the 5% significance level. So we're trying to do a alpha of 0.05, and we want to see if the training is improving their scores. So let's think this through. If we test them after the training and we subtract the score before the training, and the training really helps, we're hoping that their score is higher after than it was before. Or you're going to take a big number minus a small number. When you do that, our goal here is to get a positive number. So the way we represent positive numbers on the number line are numbers greater than 0. So keep that in mind when we write our hypotheses. So what we're going to do in a matched pair t-test is we're going to take the difference list and we're going to run the significance test of trying to get a positive number from the difference list. So it's almost like these numbers no longer exist. So now we're going to do a t-test based on these numbers. So let's go ahead and start with the hypotheses and the parameter. So we're going to start with the hypothesis of mu equals the true mean difference plates remembered. And we would like to do after minus before. And again, our goal here is to get a positive number. So if we're trying to get a positive number, that means we are trying to get numbers that are bigger than 0. That's what we call a positive number on the number line. If there is no difference between the two, like the training doesn't help, we think that they would get a 0 because if this score was the same after and before, the training didn't help, they should get a 0. So this is how we represent positive numbers. Over here to the side, I'm just going to write a little quick key. If I'm trying to do positive numbers, we're going to try to prove mu is greater than 0. If we're trying to do negative numbers, we're going to try to prove mu is less than 0. And if there's some sort of difference, you're trying to prove a difference, let's say different, because difference might confuse you, or change, we'll say mu is not equal to 0. Okay? So, but in this case, we're trying to do greater than. And the problem said let's do this at the 5% significance level. Okay, so if we're going to do that, that means we need to check our conditions. Was it a simple random sample? Was it independent? And was the distribution approximately normal? So I'm going back to the prompt, and it did say it was a random sample, so police chosen at random. It's really important chosen at random. It's important that we have an SRS so that we're not picking the smartest police officers or the dumbest police officers. We kind of have a mix of everybody. We want to check if it's independent. So there's 15 times 10 is 150 officers. I don't know how many police officers there are in a county or in a station, but just for the sake of this problem, let's go ahead and say the population is at least 10 times the sample. Okay? And then approximately normal. So what we have here, go back to our last slide, we've got data. We have to take that data and we have to graph it. In the matched pair T interval video, I used a dot plot. Just to get a little practice on histograms, I'm going to use a histogram. So I'm going to switch over to my calculator. And to get a histogram, I'm going to second y equals. And I'm going to push plot 1. And I'm going to set up my menu. I already did it. I have it on. I have the histogram chosen. And I'm only looking at list 3. When you're ready, you're going to go to zoom 9. And that's definitely not enough bars, so let's go ahead and check our window. And it looks like we're counting by 1.6. So since we're talking about words and we don't really count by 1.6s, I'm going to go ahead and change that to 2. And then I'm going to push graph. Okay, so that's looking a little bit better. I've kind of run out of space on the screen, and if I just want it all to fit, that means my maximum on my x-axis is a little small. So I'm just going to switch that to 8, just so the whole thing fits. If you don't want to do it, you don't have to. You can still just use the trace feature and trace that. So I'm going to push trace, and I'm going to see that on my number line, from -3 to -1, I have 1 police officer that remembered -3 to -1. Then I can use the right arrow key. From -1 to 1, I had 5. From 1 to 3, I had 4, and so on. So I'm going to use that trace feature to go ahead and draw that on my paper. And I get this. So I get something that looks kind of skewed right. I labeled my x-axis and I labeled my y-axis. And remember, this is the origin, so this is 0, 0. So I've seen some of you guys try to put the whole graph in this quadrant. But if you have negatives, make sure you're putting it in this quadrant, because remember, these are positives, negatives, and positives. So we said that this graph is skewed right. So I make a comment on what I see, and then I make a comment on what I want. So I said the histogram is skewed right, so assume distribution is approximately normal, because it's not, it's skewed right. So you're saying, hey, I see the problem. Let's go ahead and pretend it's okay. And proceed with caution. Okay, so now moving on, I'm ready to do the problem. So to do the problem, the formula is statistic minus parameter over standard deviation of the statistic. So if I wanted to do this by hand, I could go to my calculator and go to stat calc 1 and pull up, sorry, let me get rid of all that, stat calc 1 and pull up all the statistics for list 3. So there I've got my x bar, I've got my standard deviation. So if I wanted to use that, I would have 1.53 minus mu, which we defined earlier, is 0, 2.19 over the square root of 15. Now to save a little time, I can go ahead and just switch over to the t-test on my calculator. And so I have data. The null hypothesis is 0. We're testing list 3, and we're testing greater than. And it gives you your t-score, your p-value, and then those are the values we got from our one variable statistic. So we get 2.69 with degrees of freedom 14 and a p-value of 0.0086. So 2.69 would be somewhere around here, and it's greater than, so it's just a tiny little piece right there. and that piece is about 0.0086 or 0.86%. That's a really small p-value, smaller than the 5% alpha that we chose in the beginning. So when the p-value is less than the alpha, we say reject H0. So you're saying that when we said that HO mu equals 0 and HA mu is greater than 0, you said reject that idea. This idea cannot be true, which means you proved that. So let's write that out. Let's write down what you just did. So we're going to rewrite the HA. We do have significant evidence at alpha equals 0.05 that the true mean difference A minus B plates remembered you can say is greater than 0. You can say we do have evidence that the true mean, you can even get rid of difference and say that the true mean plates remembered after the training was greater than before. That might be easier. All right, guys, thank you so much for watching. I know you guys are studying and I really appreciate your hard work. Have a great night.